Hi, everyone. This is the SEBA call for April 16th, 2019. The item we have on the agenda this week is a continued discussion of events and performance data in SEBA and Volta. Les from Tellabs, Les Murray, made a presentation, and we wanted to talk through that and try and help better define this for both the SEBA and Volta communities. So, Les, are you there?
Yes, I am.
Okay, I'm going to pass presentation rights over to you. Is that okay?
Awesome. That'd be great.
Alrighty.
All right. So, can you guys see my screen okay?
Yes, we can.
Yes.
Okay. So, so basically, I just wanted to give a little bit of input on the alarms discussion. I've done a fair amount of alarms work over the years and have done definition of alarms on tons of different systems. So, you know, from a background, I have a fairly good background in alarms. That being said, I'll also say that to this project, I'm a noob, so I may revisit old territory or may, you know, cover things that are not necessarily relevant to the way the architecture is constructed. So, you know, I have a background in the area, but if I go places that it doesn't make sense, you guys feel free to let me know and give input, and I'll try as quickly as I can to come up the curve on you know, on these subjects. But there was some good discussion on alarms, but there were some things that I wasn't hearing that in the original discussion that we had at the lockdown that I wanted to you know, kind of address. And so first is the alarms versus events. And so alarms have persistence. So when you have an alarm, that alarm has a set and a clear. So you know, there is some persistence of data there. And you know, an example of this is, you know, like with the PON, you might have a PON or an ONT LOS, Lawful LOS, and that alarm gets set. It persists for some time, and then it actually clears. So it actually has a state associated with it of either set or clear. So events are a little bit different in that they are notifications which don't have a persistent state and simply record an occurrence of an event in time. So they use typically almost all the same types of reporting criteria, but there is that marked difference. So an event is typically reported immediately on the detection of an event, and that contrasts with alarms, which are typically integrated. So some examples of something that might be an event is a card switched to protection, a download was complete, a user logged in, a user failed to log in, you update a certificate on a device, something to that effect. So it's something that occurred. Once it occurred, you reported it, and then that's the end of it. It doesn't have any persistence or state. So as an example, all the threshold crossing events are typically in that category, right? So you cross a specific threshold, you report it, and that's the end of it till the next reporting period. So, and in the past, we've been able to manage alarms and events pretty much with the same data structure or data schema but they just have slightly different behaviors.
Les, this is
Yeah.
David. Absolutely agree with this. One thing I was going over in my mind as I was walking through some of this is what's on Kafka, or on the message bus, if you will, with respect to alarm, is essentially an alarm state change notification or an alarm state notification. And so when I was going over this, I'm like, alarms aren't put on the message bus. It's just their transition states are. And then if you query them, of course, you can get their persistent state back. Does that kind of align where you're thinking as well?
Right. So with any alarming system, right, you typically you have indications, right, alarm indications, and you'd have one of a set and you'd have one of a clear. And somewhere in the middle, you typically have some mechanism which maintains the current state for alarms. Yes, and
So,
the one, go ahead.
so Les, do you feel like that the state maintenance is something to get pretty specific? Do you think that that's something that belongs inside of Volta, or is that would that be something external? Like, would you have an alarm microservice that would maintain the state and clear information and provide an API for that? Or is that something that
Um,
might not be inside Volta? It might be a separate component that is configurable, or obviously would probably be included in the SEBA as a whole.
Yeah, so that really depends on just kind of how you want to structure in your architecture, because I don't think it really matters. I guess at a high level, somewhere within the architecture of the Volta uh, component, it seems like you should be able to ask about that state, because typically that's the entity I would question for that. But I could certainly see it being implemented as a separate service, because you simply have a flow of state indications coming in, or event indications coming in, and you need something that can maintain them, and that's a very generic thing, and it could be within the Volta core. It could be as a separate microservice, because this particular behavior is not that unique, right? It's something that, if you look across the telco state, of things, I've been doing this for the last 30 years, and it has not changed, right? The things that I just told you about, that's the behavior that I've seen when I first came into the industry, and still is. And so you could clearly build that behavior as a separate module, and do it that way, and might be somewhat more reusable for other things. But the long and the short of it is, there's plenty of ways you could physically construct that, right? And I don't really have an opinion or a real view as to which is the best.
But there aren't there two aspects here? And as you said, alarms are persisted at the source, right? Absolutely agree with that. So
Well,
there is a source device that is keeping that register that is set or unset, and the event reflects that up to something else. Anything processing those events, clears and sets and clears, is trying to keep in sync with the actual persisted state on the device. And if it misses a message or gets a message out of order, it is no longer in sync. And so there is a periodic resync that almost has to take place, which becomes more of a query to say, hey, am I really in sync? In terms of Volta, I'm not sure where the alarm or it's, well, basically there's real physical hardware here. So there is an ONU or an OLT where these alarms will be the authoritative source. Everything else is a reflection of that. And so the question becomes, is Volta, any component in Volta, meant to try to keep in sync with what's on the hardware, or is it just going to process events to some upstream surface and then allow a query to come back down from that upstream service to get the physical information from the device.
Yeah. And by the way, when I spoke about alarm integration at the source, because that is one subject I feel very, very strongly about, having lived with it painfully so many times, is so let's talk about the indication of alarm set or an alarm clear. Essentially, those typically in most telco systems have an alarm integration period, typically of 2 to 5 seconds on set and up to 10 seconds on clear, and that's to provide hysteresis. Because I've seen plenty of systems where you have misbehaving equipment and you get easily 10-20,000 indications per hour, which clearly you don't want to arrive at Volta, right? That wherever the indication is being detected, it needs to be properly integrated before the indication is reported. Because if you report the raw indication, when you get twitchy hardware, you can live a very painful life. In some of the systems we've done, that were network wide, you'd have problems where you'd be getting 6, 10, 12 million alarms per per day that you were having, where clearly if you had proper integration and hysteresis, you would not have that. So I guess the only thing I was trying to contrast is the difference between alarm integration, which is that 2 seconds in, 10 seconds out of reporting the indication, which must be at the source, which is at the open OLT in this case. It needs to be to be integrated at the source where it does not pound the upstream elements, Volta and all the OSS systems upstream. And then secondly, which is where the persistence of state is for the set or clear, so that and let me step down maybe a couple more slides, because where's the slide that I'm looking for? I don't know if I still have it, but basically what I was going to try to say is that you have alarm history, which is the list of all alarms that have occurred to whatever depth you want to save them. But you also have what is a list of current standing alarms. Where that occurs, there's two places you could have that, and one place is on Volta itself. You could push that all the way up into the OSS systems. My own personal preference would be that it be somewhere in the neighborhood of Volta, either as a separate service or within Volta, and that's where that state would persist. You made another point about synchronization, which clearly you're going to have some type of mechanism to ask the current state of any alarm sets, and that mechanism probably needs to exist on the adapters and open OLT somehow, so that you can ask that and sync that state, because you can sometimes get out of sync, and you have to ask that question either by loss of comm to the device or some other mechanism. So that's definitely another mechanism that you're going to have to to have in there. And how is it implemented today?
One question, Alyssa. So the definition of events, notification, they're reported immediately, right? So I mean that's we want to differentiate between events and defects, right? So events may still be integrated in some fashion, right? For instance, a threshold crossing on temperature may have some kind of exponential moving average integration function, but it's something that's not a standing condition, I guess.
Yes.
It's not an alarm, right?
Agreed.
So I mean, we don't want to flood the system with millions of events, also, right? So there is some I guess threshold, some integration function around events potentially, right? I mean, obviously some things are pretty clear, like switch protection, right? Once I switch protection, there's some integration mechanism that would stop it switching back, or it may be just non-revertive or revertive, but there's always some integration function that prevents lots of events coming up, right? So I guess do we want to just add a definition of defects as being something that's used by events and alarms to initiate the integration or thresholding or
Sean, I'm trying to understand what you're talking about in terms of defects. Also,
so
just as a general comment around after that, it would be I look at Volta as a source of events, not necessarily Volta processing events. Because I see an upstream system processing events, but that's separate from defects. So
yeah, defects are at source, right? So like on a physical OLT. So I may have I don't know, also frame, something that I may need several events consecutively or within a period of time that would cause an alarm to be generated. So those are the defects, they're the underlying conditions that are used to integrate alarms or events.
Okay, so we had talked about that in one of the previous Volta meetings, that those were going to be turned, multiple events or a sequence of events were going to be turned into an alarm in an upstream system.
Well, yeah, so that, I guess that's where we get to the source processing of, or where is an alarm generated, right? I think we'd stated earlier that the alarm would be generated on the physical equipment itself, right? Or in most cases, I guess there's probably situations where Volta may have to do some integration or SEBA somewhere.
Right, but then we get into the persistence issue, right? When an alarm is generated on the hardware itself, it's got that alarm state in a register somewhere.
Yeah.
Right. If an alarm is being generated from a sequence of events, that state isn't necessarily on a register on the physical device. It's been interpreted by an analysis system.
Well, and when you're doing post analysis, yeah, that to me is kind of in a separate category, right? Which is, that alarm analysis or whatever, right?
So I would almost say, well, and I come back to that. The minute I've got a post analysis that is generating a quote unquote alarm from multiple events, I don't necessarily have any persistence of that state. It's an alert, absolutely. It's an event, absolutely. But it's lost that persistence, perhaps. That's part of this integral definition of alarm.
I don't know about that, and I'll give you an example. So,
okay.
Typically, on most systems I've seen, you will have ONT LOS, right? So an individual ONT gets a lawful loss, and it's detected at the OLT, right? And he goes, okay, so that ONT has gone away. But typically, if all ONTs experience lawful loss, you will generate a new alarm called PON LOS and suppress all the ONT lawful losses. The reason being is, you also have to ask, what is the goal of all this? The goal of all this is to point the service provider to the proper location to take action. And in that case, when all the ONTs go away, it means that really something's happened at the PON, either at the OLT or in the feeder fiber or something to that effect, and you've lost them all. And typically in that case, what you do is, you're analyzing alarms, you get all the ONTs go into lawful loss, you create a PON LOS and suppress the ONT lawful losses. But it still has a set, right? The PON alarm still has a set, it still has a clear, and there are actually side effects to the clear, right?
Okay. But do you
Because
see
in
that
that case,
in that example, is that alarm still happening on the hardware, or is that happening in the software layer above the hardware?
that alarm would still continue to happen in the hardware, so you would
Okay.
still have an ONT lawful loss. The PON LOS is only a outcome of analysis, right? It doesn't have a real analog in the hardware. And also, by the way, I have some slides later on that I'd like to cover, which kind of cover some of these details, but at the point in time when that PON LOS goes away, i.e. you start seeing some of the alarms come back, you typically remove that hierarchical suppression, and so now all the ONTs which are still an alarm show back up, because you want that to happen, right? Because
Yep.
If, for example, one of the ONTs really did go bad while the PON was down, then you want that to show back up. And so,
Yep.
So to say it a different way, most of the time when you do these types of analysis, what you're typically doing is you're suppressing alarms which are truly standing, and so knowledge of those standing events still needs to be kept. It may not be reported upward, but it typically is needed to be kept at wherever this quote alarm function occurs, and so that when these higher level events go away, you can properly assess that. And it's also important that those alarms kind of remain standing, so that you can get proper outage durations. Because one of the other things that service providers typically have to calculate is outage duration.
Yep.
And so typically you want the set time to clear time to be calculable, so that you know when service began to be rendered again, because it typically has reporting requirements. It typically has time to closure. Typically there's a metric of time to closure for the field personnel. So that's also something that is measured. So that's why one of the reasons why, in the background, as an example, you often hang on to those alarms, so that when hierarchical alarm suppression goes away, you can reveal them properly, but also B, so that you get proper measurement of time of alarm set to time to alarm clear, which gives you outage duration.
So if like the adapter, whether it's the open OLT adapter or another adapter, is going to be performing analysis on the events coming up from the device and synthesizing an alarm based on a potential sequence of device, that means that the open OLT then has to deal with the persistence of that alarm state over failure, so that it can then be queryable. And that's perhaps a new requirement on the open OLT.
Yes,
so,
and you also have kind of a little bit of an oddball type of thing going on, in the sense that because you actually have the OMCI really occurring physically on Volta, a lot of the alarm detection actually is ending up happening on Volta in the adapter, and the open OLT actually has no clue what's going on, right? Which is a little bit odd and a little bit atypical from the way things are typically. I mean, I've seen plenty of systems where you have a lot of these reporting, filtering, and other functions remote, but it's a little bit odd that the actual indication will also be remote.
I guess part.
Go ahead.
Yeah, I guess part of my concern about doing this type of analysis in Volta, any component of Volta, whether it's the adapter or the core, is it seems to me that we end up in Volta then re-implementing capability that is already found in many, many alarm processing systems that could just be upstream of Volta.
Mm-hmm.
And so there's a balance there between, in my mind at least, between saying, let's pass the events up, and yeah, we're going to have to do some squelching. So if we get 1 million events, we're going to give you one with a count as opposed to all million. But let a system that's already been built and deals with synthesizing alarms or alerts based on sequence of events deal with that, rather than try to implement that in Volta itself.
Mm-hmm.
It's kind of, let Volta focus on what it does well, but let other systems focus on what they do well.
Mm-hmm.
I think I agree with David in terms of just separation of concerns. It seems like having the alarm synthesis happen outside of the adapters would also be a nice way to share that code.
Mm-hmm. I don't have a strong opinion about that. For us personally, we'll still have to construct that because a lot of our systems are enterprise, and so that OSS layer doesn't exist. But also, I'm not convinced today that that analysis layer exists for a lot of those types of things. I don't know for certain, but typically a lot of those were being done by element management systems before being passed to OSS. But
is this analysis done within something like the NEM layer? I mean, is that where it would occur as opposed to external?
For us, it's varied. A lot of times it was on the OLT, but we also did put elements of it in an element management system, but typically not in the, or at least all the ones I'm aware of, it was in one of those two elements before it went to the OSS.
Typically the EMS would do some kind of processing of the physical systems alarms. I mean, but in this disaggregated model, would it be, I guess, appropriate to do the processing of the alarms and the events in something that sits above the Volta layer, and it's kind of like the NEM type layer, and then it would go to an external EMS or OSS BSS system?
Mm-hmm.
Or wouldn't there just be an EMS essentially on top of Volta? Whether that EMS is NEM or not is debatable, but from the infrastructure perspective, Volta is just a device or multiple devices. So I would think the same paradigm could work.
So we do have an example in the NEM. We can consider it a proof of concept, sort of, because it's only the first one that works like this, but an alarm that is generated in the NEM by analyzing events and aggregating information that comes up from below, and that is an alarm that detects fiber cuts between the ag switch and the OLT, and integrated some information like subscribers that were affected and such. So we do have one of these. I did it sort of without looking at much larger context of how we might want to implement more. So, like I say, consider it, a proof of concept or an example.
Yeah, I think a legacy system though, there's a lot more alarm processing that occurs. So like root cause analysis or like a hierarchical type analysis that Les was mentioning would occur on the physical OLT. So, and the physical OLT was also capable of changing the alarm priority or changing the description of the alarm. I mean, all those things I think seems like we want to kind of disaggregate that kind of function, right? And whether that would be done via an external EMS or a function in the NEM, I think we need to, kind of discuss, I guess.
So Les, if you want to continue, we've been hung on your first slide for a while. I'm not.
Yeah, no worries, no worries.
Discussion's been great.
Yeah, no worries. So also, I just want to make sure because when I put it in presentation mode, on one side it's showing me just the first the title slide. You guys are seeing the one that says alarm terminology, right?
Yeah.
Okay. I just want to make sure because my other screen is showing me still the first slide. I hate that new presentation mode on PowerPoint. It drives me crazy. All right, so we talked about integration, and I still want to say it's critical that happen at the source, or you will pay in massive pain if you do not. But so logs. There was one other kind of discussion that I kind of heard, and I thought I wanted to make a clear separation of alarms, events, and logs. So something about alarms and events is that it is a structured thing that you have consumers for, and typically drives OSS system and dispatch behavior, right? So one of the other things that has been drilled in me over a long time is typically the alarms that you want to report are alarms that require dispatch, because typically in most instances reporting something that doesn't result in somebody doing something are not overly germane and probably will get chucked on the floor anyway, as they don't care. And so I wanted to also kind of make that distinction of logs, and that there should be a logging mechanism, but that alarms and events shouldn't be confused with logging, which is how you debug the system is intended for understanding how the internals of the system are operating, and is for diagnostics and of the software, and that those types of things shouldn't necessarily be muddled in together with alarms, which are things that you're going to dispatch on. Somebody's gonna get an alarm ticket. He's gonna jump in a truck and go do something, as opposed to logging, where typically you have your subsystems, you have some type of level to logging where you can say, hey, this is log level 3, this is what's going on, I just got this event, da 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 da, right? And that would have a different definition, different subsystem, different mechanisms for getting a hold of it. And so I just want to make sure that that was also a clear distinction in the Volta SEBA architecture. Is that true?
I can speak to that. So currently it is a separate. It goes through a separate channel, but it uses the same Kafka mechanism. So we have both. On a lot of things, we have both logging and events going through Kafka, but they're on different topics. One of the other things we have is we have some structured logging capabilities. We have the ability to attach fields to specific pieces, specific log messages, which is useful, but currently we don't have a good alignment of some of those field names. For example, serial number, it might not be, the serial number of an ONU might not be reported using the same field name, and trying to converge those all onto one common set of field names would be useful for somebody analyzing the logs. One of the things I think to speak out.
Also, transactions, when we talk about a distributed system, to understand the flow from one component to the other is important in the logging.
Exactly.
So having timing and alignment, is that what you're getting at?
Not necessarily timing alignment, although that's important too. But let's say I make a call to the CLI, or right, I do something to CLI. CLI needs to log, hey, he's just said add device. That goes to a gRPC element, to another component. That gRPC element needs to say, hey, I'm transaction 1. I got an add device, and now I'm going to go call into the core. In the core, it's got to say, hey, I got a transaction 1. I'm now updating the database, right? So when I look at my logs, I can say, show me transaction 1, and see all the logs associated with transaction 1 and the flows between the system, including potentially delays between components. And that can be very useful for debugging to understand why transaction 1 hung, why, where the error happened. So that's part of the logging. Another aspect is, in terms of Kafka, in a production deployment, I may separate my logging onto a completely different Kafka cluster than my eventing, so that I can prioritize perhaps my event stream for alerts and alarms, because as you said, the reaction, something has to happen, where log is often post-mortem. And so that could be a low priority.
Yeah, I agree with that. One of the other things to call out is that logging isn't acted upon by any automated system. So, for example, other things are going to be consuming events, whereas logs are only human consumable usually.
Yeah, agreed.
Yeah, and I think one of the things David was also talking about is just just traceability. And so there are tools out there and projects like OpenTrace that might be able to support, this capability to track down what exactly occurred.
Yeah, and hopefully whatever logging mechanism you have can be turned on and off via your CLI, or turn on levels of logging, because otherwise it tends to chew up a lot of processor that you don't necessarily want all the time, right? You want it when you need it, but not all the time, right?
Well, yeah, this is for the traceabilities where I think the breadcrumbs become important. And then you get interesting systems that say, hey, I'm watching my event stream. I've noticed an event. It may not be an alarm, but now I want to, based on some policy, up logging in a certain component for the next 5 minutes. Right? And so you can get those kind of interesting interactions.
Yeah. And one other comment was, are you guys logging all the CLI inputs? In other words, an event that says CLI command X was issued by Fred?
Not within Volta.
Okay. I was just curious about that, because a lot of times for backtracing who caused the outage, that's something that's been...
Yeah, you want that audit capability that user Joe issued this CLI command, and now we're going to go fire Joe because he brought down the network.
Exactly. And yeah, I've had people on me about legal ramifications and stuff. So just a comment that's one place where kind of the logging and event kind of cross over, in the sense that you need to have events or logs, one of the two, that are measurable back to a user. So.
Well, that also goes back to your point about downtime measurements. There are often legal and monetary ramifications if I violate an SLA with a given customer.
Yep. So some other concepts. It's called by the Broadband Forum alarm definitions and alarm inventory. I guess I would call it an alarm dictionary. which is typically it defines the format, the severity. You know, it often controls your reporting at a global level, and I'll show an example of that in a little while. I mentioned this earlier, but the current alarm displays all the alarms that are set, and the alarm history, right, which is your log, which typically you need an upper limit set on your storage. You know, standing alarms need to somehow remain in storage. So that's why typically what you'll see is you'll actually see a table for the current alarms and a separate table for alarm history, because typically the alarm history, it has to be a bounded element, because you simply can't hold all the alarms over time, right? You often go into systems that have, you know, a couple 100,000 alarms that have come and gone. So you have to bound that alarm history. But you could have an alarm standing for years and you still want to be able to see that it is standing and that it has been standing for years, where typically it would fall off the bottom of your alarm history. So that's why typically you typically have two separate tables, one for the current alarms and one for the alarm history. So you mentioned this earlier, but basically a correlated alarm is one that's based on the analysis of subordinate alarms. And I gave that example earlier about the PON LOS. And we kind of discussed hierarchical alarm suppression. And there's one other concept we haven't talked about, which is alarm upgrades. So sometimes multiple alarms can upgrade the severity. So like if you looked in the dictionary, the severity might be minor for a GIGI going out, but you might get an alarm upgrade if you've had multiple link failures in your lag, because you're starting to degrade the system. Because typically, if you got a multi-link lag for your NNI, you know, typically it's a minor for you know, maybe one of those links going out, and often you'll upgrade that to a major as the other things happen. Now, one of the other things I'll say is to how some of these things happen is, you know, I know you guys are wanting to push northward for a lot of that functionality, but often some of that functionality depends on knowledge of hierarchy and architecture, and so sometimes it may be difficult and push a lot of knowledge that isn't wanted northbound, right? As an example, you know, in the example I just gave, you'd have to understand, you know, how many links there are, how many links are in that lag, etc. Right? So, I mean, it can be done. It's just in the past I've seen real resistance to pushing any knowledge of that kind of stuff northward. Right?
It seems like you might want to have a category of alarms that are on the physical device itself, another category that would exist in Volta, and then maybe other categories that exist northbound of that.
Mm-hmm. Yeah.
In terms of alarm upgrades, where do you typically see that upgraded severity or priority being applied, and where do you see that persisted?
Well, and you, I will say 100%, you can definitely do this in multiple physical locations, and nothing would preclude it working well, you know, in different physical locations. In my personal experience, it's always been on the OLT or the network element, but that's a little bit more of a function of just the history of things, right? It's not necessarily a that it has to or needs to be done that way. It's just that's the way a lot of things have evolved, and you know, typically most of the state was maintained within the device. Now, this is a disaggregated function, and to me, a lot of those have moved into Volta because it is taking over a lot of this and a lot of these concepts. But you know, nothing precludes you from, you know, moving that behavior even farther north. You know, I personally tend to lean towards having it as low in the hierarchy as possible for multiple reasons. One is because you don't share northward information which isn't going to be acted upon. Secondly, it tends to isolate the knowledge of architecture at the lowest element that can do something about it. But you know, I can see both routes, and I also personally will admit to having a you know, desire that it stay lower as well, because you know, in enterprise, and which is a large part of my business, it's there is no higher level system, right? So if it didn't exist in Volta, then you know, it doesn't exist for me, right?
Okay.
So so I think we covered all this. Oh, one other thing is, so typically, because you can often have alarms that are standing, but you don't care, often you'll have something called an alarm acknowledge, where in essence what you'll do is, it is an alarm, it is a standing alarm, I want to acknowledge it, and you're no longer going to report it northbound. And that is done on an instance of an alarm, not a type of alarm. Because typically when you're doing filtering, you're doing it on a type of alarm. And the reason why that is nice is because, you know, you may not want to drive out there and go unhook that cable or unconfigure that device, because maybe it's configured by an OSS system and going through the shenanigans of getting it turned off just to keep your alarms display clean. So often people will have the ability to have an alarm acknowledge, where you can act the alarm and then it no longer shows up as an acknowledged alarm. You can also set that as just an attribute, which could be filtered northbound.
Yeah.
But
Yeah, the question is that done as a filter on the device? Back to your comment, you know, if I want to acknowledge you're no longer send me this alarm, I can potentially go back to the source and say filter out this alarm, right? Don't send it up. Or I can do it at kind of the display level, which basically is a filter, show or not show.
I have to say, I haven't thought about it that deeply, and I'm trying to remain as open as I can in terms of not letting experience, you know, prejudge things just because you've done it a bunch. Because there's a lot of powerful, nice things about the Volta architecture and the disaggregation. And so I think it's something that bears more discussion. Because the way I saw it is, we're going to have this discussion. You know, people are going to go off and think about it for a while. And you're going to have another discussion where you actually start talking about that. Where the heck do these functions occur? Because I think they need to occur. The question is where, and I think it's better that you know, everybody go off and kind of think about it for a while, you know, and come back, because I think you'll get a much better mix of ideas and you know, a better consensus. I just wanted to get all the concepts out there.
Yep.
And then you know, probably after a little bit of delay, then come back at it and have a discussion of, okay, now we're going to turn this into code. How do we want to realize this, right? And once again, this is one of those functions that you if you have an attribute for acknowledge, you could do this anywhere, right? Anywhere along the chain. And it's strictly a choice of what makes the most sense, you know, for the architecture.
Does
So
does
go ahead.
that acknowledge end up in the audit log as well?
The act of acknowledging an alarm.
Right.
Yeah. Typically, I mean, I can't speak for everybody, but for us, we do a lot of DoD and FedGov work, and so there are hard and fast rules that every action, no matter what, big or small, if somebody makes a physical change to the system, it has to be logged. So in our case, the answer is yes. You know, if you acknowledge alarm, if you make any change to configuration, all of that shows up as logged data that they can go back for legal purposes. So I mean, personally, I would log all that. In this type of system where you have lots of resources, it's not that expensive, and you know, you can typically do these things as a consistent thing, right? Like your CLI always logs that this is happening, and that type of thing, right?
Yeah, we've Volta has a lot of work around there, right? Because I suspect most people that interact with Volta log into the CLI as Volta admin, right? Which just
Yeah,
completely blows all security whatsoever, or all auditability.
And they probably are sharing
Yeah,
an account and all that kind of stuff. Yeah.
yeah,
Yeah. As long as the avenue exists, I think that is the best route, right? So the next subject is on that alarms inventory, and this is kind of what I have seen as kind of more canonical forms is, you know, in configuration for alarms, there's an alarm probable cause, right? That's your LOF, whatever your event is. Your alarm severity, you know, your critical, major, minor. Often there's a category. That is very helpful because, as an example, I don't know if you guys do this, but because we're more in the enterprise space, we have a lot of syslog interfaces, and a lot of times you'll have a security department which will you know, log all the auth type events to one place. You'll have a different guy who's in charge of the physical hardware, and he'll want to see some subset that's typically the equipment alarms. So it's often quite nice to have a category that allows easy filtering, right, of large categories of alarms and events. You know, and if there's also typically some configuration of what the text associated with the alarm will be when it prints out, and that smooths things a lot for your CLI type stuff. So like this is a typical alarm template that we have, and you can see, you know, there's some enumerated value for the thing, the what the reported text is, what the category is, what the probable cause is. This is something that's typically been done is in all the NMA and other reporting systems. Typically you have whether or not an alarm is service affecting. So you know whether it's an immediate dispatch or not, and then reported severity. So that's kind of like here's how you would program alarms. So like this would be a configuration table for alarms. Then that would be used when you create an alarm instance. So, you know, an alarm indication occurs, the alarm indication is reported, you use the indication along with the template to create the actual alarm, and then you know, that allows you know, the service provider to control the severity. It allows you know, the string or whatever to be configured. If you want to see a different physical string for a given alarm, you can do that, as long as there's some enum value or something that gives you the indication that goes along with it. But that's kind of like what you would have in the config for an alarm.
So this
And
lets,
it's also, go ahead.
yeah. So this lets the operator sort of customize the alarm functionality for their system, and also maybe does this also function as a localization tool, because the localized text might be different depending on.
Yes.
It might be
Yes,
in.
and also for those of us that have to deal with multiple languages, it allows you to change the alarm to the language of the target audience. And the other thing is, when you look at the actual alarm indication reporting, that becomes a generic function, because all you really need is the fact that a given alarm type occurred and the associated alarm or event number, right? The magic number that's this is that event. That's all. That's mostly all that the lower level primitives are reporting, right? And all this other thing, all the rest of this gets, as you guys, I guess, say, is adorned or enhanced when this alarm starts to be processed, right? So down at the lower level, you just got a primitive that says, you know, report alarm or report in event, and you have the event number, and typically one other element, which I'll talk about in a minute. But that, you know, basically that's about it. And it also makes it a whole lot easier to add new alarms, because you just add a new table entry and then put the primitive wherever it needs to be, you know, detected, and then for the most part you're done, right? You don't have to plumb it a whole lot of places, or carry around a whole lot of data, right? So one of the other things which I feel is very important is being able to, with an alarm or event, to carry along an unstructured text field that is reported by the endpoint. And this is a very useful thing, because having generated a bunch of these, what you find is the alarm itself structurally is fine, but there's all this other junk that you really actually need to tell somebody, but you don't want to have a million little data structures crawling all around with, you know, schema associated with it. I'll give you an example. Is like when you have a login event, a lot of times you want to log that, and you want to log the user, you want to log what IP address they came from. You know, whenever you know, various events happen, a lot of times you like whenever a certificate goes to expire, a lot of times you want to tell the date on which it's going to expire. If you had a link failure based on a bad certificate or bad credentials, a lot of times you want to say what the credentials were that you received, but you don't necessarily want to burden the whole alarms infrastructure with, you know, knowledge of all that structured data. And so typically what you know, we used to do that, and it was a mess. But you know, once we started just sticking a freeform text field on the end that allowed you to, you know, tag along a little bit of structure, you know, a little bit of text data, that you could put all of that other additional stuff in, it actually went really well, and you know, was really useful. And I think that's a nice little add-on that has done, you know, a lot to help clean up alarm and event reporting, so that it was just one thing. We never change it anymore, and you know, you still can report all the information that you need to upper level systems. And also it's nice for dumping out into syslog. So I know we're at 12. I still have a little bit more to go. I don't know how tight you guys are about stopping it at the end of the hour.
I'm fine with continuing, but there may be people who have to drop.
Okay. So so filtering of alarms. So another concept is filtering, and typically filtering does occur in either A, upper level management systems, or B, at the periphery of the reporting system. And I've seen and done it both ways, and both work. You know, it's typically subdividing all the things that are being reported into communities of interest, things that are of interest to specific entities. As I noted earlier, like typically you have a security department and they want all the auth events. You've got somebody who's in charge of the OLT and they want all the OLT alarms. You have outside plant, which is responsible for the ONTs, and they need the ONT stuff. So filtering is typically temporary, and it should either be done at the system of interest or at the peripheral of the reporting system. And I got a couple of slides where we can talk about that. Oh, and one other comment that I didn't mention above is in the alarm definitions, typically we have, and this is traditional Telcordia stuff, is there's not alarmed and not reported. So not reported is an alarm that you keep track of, but you don't report it to the higher level system. If you went and asked me about it, I would tell you it was standing, but it doesn't go up in the events that go northbound. And then there's also not alarmed, which is I don't even keep track of it. So that's often, and the reason why I mention that is a lot of times you have kind of like policies as to, you know, in my network, I just don't care about that alarm and I don't want to spend any compute cycles anywhere on doing something about it. And so doing a not alarmed means that, you know, you don't report it northbound, but, you know, if I was debugging a particular situation, I could go ask the alarm state and it's there. Or, you know, not alarmed, which is I couldn't even ask the question whether that occurs. You know, typically when the primitive is reported, you just dump it. So, so there's two different, and I will also say that the internals of Volta are intentionally drawn as a black box because I'm still coming up to speed on this, so I don't know the internals, and you guys have much better insight into the right places and the right components. But I wanted to express two different concepts. One is alarm filtering, where alarm filtering occurs somewhere within Volta. And that's one mechanism. And typically it would happen, you know, or you could actually do it in the devices above. Okay, I got myself confused and I apologize. Okay, so this is the picture where I was saying that filtering could be applied by communities of interest within them. In this example, you would report every alarm and every event, and the systems that are interested would either use or discard them. This is, I think, what you have today, which is everything goes straight through Volta to northbound systems, and you would have the concept of filtering within the northbound system. So so this is one option. Another option that you could do is, and this is oft used. Syslog is a lot this way typically. So you can have the external systems give filter criteria, and you can have filtered alarm or event. So in this case, the filter criteria are probably in whatever is at the northbound end of Volta that reports to upstream systems. In that case, the upstream systems can give you filter criteria. They get filtered alarms or events, and it's typically per interface. In other words, filtering is configured per connection. So in this case, you would not get events at the end systems that you didn't ask for. So this gets rid of a lot of events way back at Volta that would not have to be processed by the end systems.
Does that kind of, what do I want to say, suggest that there is a persistent connection between the source and the sink of these events, right? It's not like we're listening. If I have multiple clients on a Kafka bus, it would mean each has its own subject to listen on for its events in order for that to happen, so that one doesn't accidentally suppress events the other guy wants.
Yeah, and this is where I don't know what interfaces you guys are anticipating with the northbound OSS, and that's one reason why I also drew this picture quite nebulous, because I don't literally know what you guys are going to do. It doesn't necessarily have to be persistent. As an example, you can run syslog as a persistent connection. You can run syslog as a UDP connection, but the filter criteria are persistent in the end system that you are getting events from.
Yeah.
And I guess all I was trying to, the difference in the two pictures I just showed is, in the first picture, there was no filtering going on in Volta, and everything was going to all consumers, which is, I think, what you have today. And that is very expensive for the end systems, but very easy for Volta. It also leaves it very open for, new interfaces and events, and multiple consumers of the same event. This also, you can do pretty much all the same things. It's a little bit more expensive to implement on Volta because you have to allow configuration of filter criteria. But to your point, that it would have to be per a particular relationship. I mean, typically the way at least we do this today is it's based on the destination, because what is true is you have to somehow have an end station destination, which this data is going to, especially if it's UDP. And that typically is how we've configured it, is either the IP or host name of the end station destination, and then the filter criteria. In fact, like, we can have syslog, and you can have 3, 4, 5 destinations, and each one can have their own filter criteria. And so the syslog collector in the security office can get all the auth events. The syslog collector in the, in the IS department can get the stuff he cares about, etc. So
Yeah,
even
that information, that it becomes configuration information against Volta, potentially persisted over restarts and all that. It's just more complicated to manage, as you suggest.
Yeah, it does. 100%. It does add complication, but the corollary to that is you report large amounts of useless data to end stations that don't really care and don't need it. And as you add new alarms or events, they may have to react to things they don't even care about, right? So,
and this is where Zach's comment, is there an internal component within Volta that essentially gets all the events and filters out the garbage per connection, if you will. Just so it's a kind of a single place.
Mhm. And my preference for sure would be that that there is some type of filtering mechanism, because I mean, just from past experience, you know, you can easily overwhelm upstream systems. Um, as an example, you know, I mean, a lot of these problems are cured by code, not by either code or replacing a device, not by you know, some type of configuration. You know, you'll have a set of alarms that will just stream and stream and stream and stream, and you start clogging up the upstream systems, and you make it, you know, they start slowing down, and day-to-day operations start getting, you know, impacted. And to me, at least, experience would tell me that the closer you can filter to the source, the better life is. But
Yeah.
you know, I totally get that it adds complication and inelegance to Volta, which in a distributed system you should be resistant to. But this is one area where it tends to overwhelm the end stations if you don't have some mechanism. Because as an example, if you had a set of rolling alarms that were just happening and you couldn't do anything about them in the short term, you just have to live through it because you couldn't filter it if you didn't have that capability, right? You just have to live through it. You just have to, you know, if 6 million alarms come in, well, that's just what happens, right?
Yeah. If 6 million alarms come in, you might have other problems too, but yeah.
Mm-hmm. Yeah, but I mean, because it tends to just, you know, the old statement about how it rolls downhill. It really does, right?
Oh, absolutely. Absolutely.
So anyway, so a couple of other little minor things. Typically, you have some kind of behaviors that alarms on an entity whose admin state is disabled. Typically, you don't report them. The reason I'm mentioning this is, let's say you have lots of ONTs attached to the system, but you know, it may be sitting on the side of somebody's house, but that's not a current subscriber to you because they went cable. If that in port is disabled, you want to make sure that all those alarm primitives are not reported. So one of the kind of things that needs to be there is, if you got an admin state on the end thing, like a ONT, like a port, like a whatever, that all alarms, when it's disabled, are not reported, and furthermore, that you clear any of them that were standing at the time it gets disabled. Because you certainly don't want to be sitting there with alarms on a system that nobody's paying you money for, right? And you don't care about. Because it's not uncommon that, you know, you have a lot of unused ports that you don't really want alarms because they're not even providing service. The person may have taken the broadband home gateway and thrown it in the trash, and it's no longer attached, but that doesn't mean you really want to hear about the link down alarm, right? Because they're not currently a port of interest to you. So typically, whenever you enable a port or whatever, you want to make sure that the alarm state is recalculated. Let's see. And I just included just kind of an example of, you know, a lot of times you have external systems and you have some way to give them filter criteria for things of interest. And so just a comment that you might have some type of configurable filtering mechanism. I also want to point to the BBF alarm definitions, which are a really good place to look at you know, a possible place to get schema and ideas from. You know, the BBF Yang definitions have a lot of all these concepts that we talked about. They have acknowledgments, they have shelving of alarms, which is what they call it when you have an alarm you don't care about. They have some of those you know, fields, the type, the severity. They support modifications to severity. They support time stamping, which is important. I don't know if you timestamp your alarms and events today, but that's critical. The related alarms, they allow you to correlate an alarm to an entity. And then alarm summary metrics, they also have a, which this is a nice little thing, they have a mechanism where you can have a summary metric of all the alarms, i.e. the number of alarms that are currently standing, and that type of thing. What the highest alarm severity is, da 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 da. It's a nice little summary mechanism that might be something nice to include. They also have filters as well. So that's another good spot. I find the BBF guys do pretty good definition work. And one of the other comments I kind of wanted to make is I would assume that a lot of the people in this particular forum may also be building something that might be based on the broadband forum definitions, and it might ease people's lives that have to deal with both if we make use of things that are being defined in that that forum, as it'll make it smoother for people that are trying to you know, have both types of systems, because they are also building an SDN based kind of system. But I always find it's really good to reuse definition work when you can get it. So I think that's it. Yeah, that was it.
Thanks, Les. If you could get me a copy of your presentation, it would be great to be able to attach that to the to the notes on this meeting.
Yeah, I put it into the folder on the
Google Drive.
lockdown,
Yeah.
the Google Drive for lockdown. And basically all that I did is, since you gave me access, I made a version 2, and this presentation is exactly the version 2, which if you clicked on my presentation on that Google Drive, you would get the latest.
Okay, sounds great. I know we're quite a ways over. Thanks for everyone who stuck around with us. We might bring up this discussion next week, or I'll talk to Julie and see whether it'll happen here or in the Volta discussion. Thank you, Les.
Okay, great.
And everyone else.
Thank you.
Thanks, Les. That was great.
That's good. Thanks. Bye.